Okay, students, we're going to dive into lesson 1-3, and we're going to continue working with functions, but we're going to pull up some features now of functions that we want to review, starting off with domain and range. So the goal here of domain and range is to find the x values and the y values that help us end up graphing this graph. Okay, so this is a bit of a review from lesson 1-1, a warm-up. So go ahead and pause and take a few seconds to quickly jot down the domain and range of the following graphs. Let's take about maybe 3 minutes and then unpause and come back. Okay. So hopefully you took the time to do that. So when you are looking to determine the domain of a graph, I want you to look at the x values. So specifically what you're doing is you're looking at the x-axis and you want to look at how far left, how far right is this graph going. And if you notice here on this first graph, the furthest left this graph is going to go is right here at this number at -6. And the furthest right it's going to go is at this number, +1. Okay, so let's put this a little bit bigger just for purposes of clarity. And I'm not sure why those numbers are so blurred out, but we can pretty much see what those are. So from -6 to +1, we can see that that's going to be our domain. So we're going to come over here. Now those values are included in the graph, so we are going to use -6 to 1. We're going to use brackets. Okay. Now, when it comes to the range, we look at what is the lowest value and what is the highest value of this graph. Well, the lowest value of this graph is this horizontal line that goes through 0, and the highest value is this horizontal line that goes through -3.5. I mean, not -3.5, sorry, +3.5. So the lowest y value was a 0 and the highest value was a 3.5. And because those points, those values are included in our graph, we will also put brackets. Okay? All right. Now notice how you always go from left to right, smallest number to largest number on either one. Okay, so the lowest value, I'll use L again, to the highest value, okay, in the range. So let's look at this next one. Now, one thing I do want you guys to be able to make a habit out of is to recognize functions, okay, be able to identify them. This one right here is not a rational, my apologies, is an exponential function. Okay, so this is a pretty common function that you guys are quickly able to recognize because of your working with exponential growth and decay. So, this is something you guys get very, very accustomed to working with. So with exponential functions, I do want you to always remember that they have horizontal asymptotes. Horizontal asymptotes. And it's important that you identify this horizontal asymptote because it helps guard you from messing up on domain and range. Okay, so for instance, notice that this graph is going to get really, really, really close to this y value. Okay, and it's the asymptotes serve as like a sort of wall, so to speak, that the graph is approaching, but it never really ever intersects. Okay, so what we usually do is we use a dashed line to depict that line. Okay, and that's what I'm going to do right here, this dashed line. And we notice that this dashed line is going through y equals -8. So I'm going to write down here y equals -8 is my horizontal asymptote. Okay, so I've identified my horizontal asymptote. Let's move on to determine domain and range. So domain, how far left is this graph going to go? Well, it looks like this graph is really going left forever. And as far as right is concerned, it's also going right forever. Okay, so it's going to go left and right forever. So that's going to be positive to negative, negative to positive infinity. Okay, negative to positive infinity, or you can write all real numbers if you prefer. And then as far as low to high value, well, if I examine the y-axis, the lowest value it's going to be arriving to is the asymptote of -8. As far as how high will this graph go, it will go on up forever. So we start with the lowest value. In this case, it's -8. Now, because it's asymptotes, you are going to use a parentheses at that -8 value, and I'm going to put parentheses around the infinity symbol, because infinity symbols always have parentheses. They're not included. Okay, now this one right here is another function. I want you to make sure you understand how to identify rational functions. Okay, I'm going to put FCNS for short. Rational functions have two asymptotes. They have horizontal asymptotes. I'm going to use HA, and they have vertical asymptotes. Okay, so in this case, when you are identifying the asymptote, the graphs are going to get really close to a vertical line that crosses through the x-axis, and this particular one, our vertical axis, is x equals -1, or not vertical axis, vertical x value. And then as far as horizontal, it looks like both portions of this graph are getting really close to the y value of y equals 4. So I'm going to put y equals 4 to remind us. So how do we write this out? Well, domain says the graph goes from the far left, okay, I just disconnected myself, so give me 1 second. Leave it to me to do that. Okay, so sorry about that. All right, so our graph goes from the far left, right over here. So I'm going to put -infinity, and it keeps moving along. Let me use a little highlighter here. It keeps moving along, but then as soon as it approaches -1, it just drops and just avoids getting close to that asymptote. Okay, so we are going to say it goes from -infinity all the way to the -1 value. So let's go ahead and write that. It goes from -infinity all the way to the -1 value. And I'm going to put a union symbol because we're not done yet, because this graph continues to grow. Continues to exist on the other side of this asymptote. So it started at -1 and it continues over to the right. So that's why I put the union symbol, and I say jump over the asymptote, continue on the other side of the asymptote at -1, and keep going right. So in essence, you're using all real numbers except for -1. That's what you're telling the reader as far as domain is concerned. Okay, now as far as range, same thought process. We are going to start from the bottom. Okay, so notice that our graph goes down forever, but it's going to keep going up, but right when it hits that horizontal line, it stops right here at 4. And then you have to jump over that horizontal line, and then you keep going up. Okay, so in essence, you're going to say all real numbers except for 4, but in interval notation, you say from the bottom, -infinity, all the way to 4, and then I'm going to also include 4 all the way to +infinity. So that's your range value. So make sure you recognize where your horizontal and your vertical asymptotes are located on rational functions. So now we're going to move into identifying if a function is one-to-one function. So you already know how to identify if something is a function from section 1.1. So if it is indeed a function, then I need you to determine if it is one-to-one, okay? So graphically, what we're going to use is called the horizontal line test. And the horizontal line test works just like the vertical line test in that you will draw a horizontal line, and if it intersects only one time, it's going to pass the one-to-one function rule. So looking over here, you have two graphs. Now here's the thing though. When you are testing for one-to-oneness, you have to first make sure that it's a function in the first place, okay? So if we look at this first graph, okay? Right now we can tell that if we were to apply the vertical line test, anywhere I draw the line, it will intersect one time. It doesn't matter where I draw the line, it passes the function vertical line test approach, okay? So we know for a fact that it is a function. So this option right here of not a function, we get to take away, okay? So now we have to decide, hey, is it a function that is one-to-one, or is it not a function that is one-to-one? So because we have passed the function test, let's use the horizontal line test. And using the horizontal line test, let's change the color here. Let's go green. We can test the horizontal line test by drawing a horizontal line, and it must intersect only one time. But we can clearly see that is definitely not the case. I mean, intersected there, there. It's intersecting like crazy. So we can definitely say that yes, indeed, it was a function, but definitely not one-to-one, okay? Whereas on this one over here on the right, the vertical line test, let's see if it passes. Well, it touches one time, touches one time, touches one time, over and over again. Now I know this piece right here is going to look like it touches more than once, but this is what we call a square root function, and it's actually, this area right here is actually going to the right gradually and also increasing. So be careful with this, and I said square root function, it's actually cubic root function. So be careful with that, okay? So it's misleading. It is definitely a function, all right? So it is a function, but is it one-to-one or not one-to-one? Oh, wait a minute, did I? Okay, yeah, I was doubting myself. So is it one-to-one or not one-to-one? Well, if I were to draw a vertical line test, a horizontal line test, I am so confusing you. There it passed only once. Here, it also passed only once. So every single time you attempt to draw a horizontal line, it is touching only one time. So it is safe to say that we can choose option B that stipulates that it did pass the horizontal line test, so it is a one-to-one function. Okay? All right, moving on. Composition. Compositions of a function is an algebraic operation in which you use one function as the input into another and perform the operations of that input function. This is a glorified substitution problem. Now we are going to just do it graphically, but in the next chapter you will see how to do composition of functions algebraically. So let's focus on number 6, okay? Number 6 has two graphs that are given to us, the F graph on the left-hand side and the G graph on the right-hand side, okay? Now, what you're going to do is always, when you start with the the composition problem F of G of -2, I want you to always begin with the inside and work your way out. Now the inside will always be your X value, okay? And what you're going to do is you're going to look next to that X value and check to see what function is it next to. And in this case, we are next to the G function. So that means we are going to start with the graph that's called G. So I want you to completely ignore this graph for now. Now, notice that I said that the x is -2. So I have to start right here at -2. I'm standing right there, okay? Right here at -2 is where I'm standing. And then it tells me to go find what is the y value of g of -2. So if I'm starting at -2, I need to actually go up, which is 4 units up, to be able to get to that g function, okay? So what I'm going to do is say f, because I haven't worked with anything of it yet, and g of -2 is 4. How many spaces did I have to go up from -2? +4. So now, notice what happens. My 4 now becomes the new x. And now I have to go to the f function, because I'm going to go from the 4 and go find the y value on the f function. So right over here is where the 4 is at. And I ask you, how far up or how far down do I need to go to touch the f graph? Well, this one's kind of a neat one. If I'm standing here at 4, do you notice I'm already touching the graph? I didn't have to go anywhere. So f of 4 actually is just 0. And I'm done, okay? So let's practice with the next one. Go ahead and attempt this problem, pause, and then come back to me. Okay, welcome back. So let's check your work. -1 is your x value, right? So let's go to -1, but where? So I'm going to look to the left and I say, oh yeah, I have to go to the f function. So which one of these is my f function? Well, it's this one on the left. So I'm going to go to -1 and stand at -1, and then I need to move. Well, -1 is right here, and I had to move downwards to get to my graph. And I noticed that I got to touch my graph when I got to -6. -6. I had to go down 6. So I'm going to bring over the g, and f of -1 is down 6. This now, my friends, becomes the new x. But this time, I'm going to go find the y value on my g function. This is my g function. So walk over here. I'm going to expand it again. Go to my -6. And I'm standing here. And I notice that I have to go up. How many units up? Well, I had to go up 5 units. So g of -6 is 5. So I hope you got that one right. And if you didn't, it's okay. As long as you're understanding from your mistakes, we're good. How about trying the next one? Pause again, and let's see if you can get this one as well. All right, you're back. So we start with 9. We're going to start with 9 on the g function. This is my g function. So let's expand this graph, and it's 9. So if I'm starting right here at the 9, where do I need to go? I have to go up. So I went up 5 squares. Was it 5? 1, 2, 3, 4. No, actually 4 squares, my bad. I went up 4 squares. So for this particular problem, my y value, g of 9, is 4. So bring over the f, because I haven't done anything with it. Now go to the 4. It becomes an x again. It's no longer a y. So I go to the 4. And if I'm standing at the 4, what did I need to do? Well, in this case, I had to go up 2 units to get to the graph. So f of 4 is a +2. Okay? Hopefully, this is making a lot of sense. Okay? Okay. Keep working at it. Let's finalize this lesson. Now, for the last bit, we are going to select 3 graphs to work these last 3 sections, okay? So what I need you to do is, let's choose a different color here. I'm going to choose this blue. I want you to call this graph the A graph. If you can please label. I'm going to call this graph the B graph. Label that one. And this last one over here on number 7, I'm going to call this the C graph. So label here on your table A, B, and C. So you'll know which graphs you looked at when we were determining intervals of increase, decrease. Okay, when you are doing intervals increase, decrease, I want you guys to visually, or you can use your pencil, your finger, trace the graph from the furthest left point to the right. So in this case, in graph A, I'm starting around this area over here. That's my furthest left end. And notice that I am going to trace it. And there's going to be a piece or pieces where the graph increases or decreases in Y values, okay? So you're going from left to right, so your X's are always going to increase, okay? But when I talk about increase, decrease intervals, I need you to zone in and focus on the Y axis, okay? So when I'm tracing this graph, what is happening to my Y values? Well, my Y values are going up, up, up to this point when it reaches the vertex. So I can put that without a doubt, this side of the graph was definitely increasing until it reached right there at that, vertex. And then all of a sudden it started to decrease. So let's write that down. So it started to decrease. Okay. So visually, I know that you can tell that it's increasing and decreasing, but how can I write that out mathematically in interval notation? Well, what you're going to tell me is that it's increasing from the far left all the way to what X value? Well, it stopped increasing right here, okay? And that X value is a 7. So the way you're going to write that notation is you're going to tell me, open parentheses, I started from the left. Left means negative infinity, comma, and it increased up till 7. And then close it off. Okay? Intervals of increase and decrease will always be written within parentheses. Okay? So whatever the beginning value and the ending value of where it increases and decreases, it's always going to be parentheses. Okay? And where did it decrease? It decreased after, on the other side of that vertex, from 7 all the way to positive infinity. And you're done. That's it. That's all you do. So let's do B now. B is this second to last graph. Let us choose a different color. Let's use rainbow here. All right. So do we notice now we're going to trace the graph from left to right. So this is the furthest left. And I'm tracing. What's happening? Okay, so hopefully as I was tracing, you said it is decreasing and that it was increasing. So let's write that down. So on this side, I'm going to write it was decreasing. And then on this side, it started going back up again. The Y values, they started increasing. Okay, so on this side of what? So again, here's where the change occurred. Okay, that's where the change occurred. Exactly that part, that value. But I need you to look at the X. And what is that X value? That X value was a 6, a very blurred out 6, but it's a 6. So we went from the left, this is left, which is negative infinity, all the way to 6. Whoops, wrong side, it's decreasing. So from negative infinity to 6, it was decreasing. And then increased from 6 to positive infinity. Okay? All right, I want you to do the last one, number 8. pause the video and you work on number 8. Where is it increasing and decreasing? Okay, you're back. Let's check. So, the furthest left of the graph is here. We read graphs just like we read a sentence off a page. Start from the left. So from here to here, something happened. And then from here to here, something happened. So what exactly happened? Well, let's choose another graph color. Sorry, pen color. Let's try purple. So first, the graph started to go up in its y values. Up, up, up. The y values increased. Then after that vertex value, the graph started to decrease. Okay, so how do we write that in interval notation? Well, where was the change going to change? Or where's the change happening from increase to decrease? Right here. Okay, this vertex, what value? That was -3. Okay, it changed right there at -3. So let's do this again. So first we started with increasing. Increasing, let me change my pen here. So increasing started from the left. So here's my increasing column, the first one. From the left, comma, to -3. Is that what I said? Yeah, -3. And then on the other side of that -3, from -3 to infinity, it decreased. And that's it. That's how you determine intervals of increase and decrease. Thanks for watching.